Okay, guys, so this is my pencast for the air rocket activity. So the first question says, sketch a diagram of the situation and use arrows to represent the position and velocity of the rocket at 0 seconds. Clearly show which way you are defining to be positive direction. So I said right here going up is the positive direction, and here are all my position time graphs. Here's for the low, medium, high, and super. So as you can see, I have the times written down for where they ended and therefore at their highest point, which is in the middle. And as you can see, they travel more distance the higher it goes. So low goes up less than medium and high and super and so forth. And same thing for the velocity graph. Now, all of them, since the Earth has a constant gravity of with the acceleration of negative 10 meters over second squared, all of them are going to have the same slope. So I tried to draw all lines with a relative same slope. And I used the ending time where the line ends, where in this graph where it hit the ground. So that's my end. And then the halfway point where it goes through 0 is at the halftime, where the slope here is equal to 0, because the slope of the position time graph equals the y value of the velocity graph. So those are my velocity graphs. And then so then from that I could also find out acceleration, because number 2 says sketch a velocity versus time graph and acceleration versus time graph. So I showed you my velocity graphs, which are right here for low, medium, high, and super. And now same with my acceleration graphs right here. So all of them are going to have the same acceleration graph because they're all going negative 10 meters per second squared, because that's Earth's gravity field. Okay, so now number 3 says, what is the change in velocity of the rocket? Explain how you figure this out. So, because they are all negative 10 t, because to find the change in velocity, you take the area of the acceleration graph, and the acceleration graph area is base times height, because it's a rectangle, right? You just make a line right there. So the base is negative 10 and the height is t. So all of the area, or the change in velocity, is negative 10t. And because that is the area underneath the acceleration graph, that equals change in velocity. So I plugged in the times that they hit the ground. So for the low, it's 2.63 and so forth and so forth. So here are the change in velocities I got. I'm not going to tell you, all the numbers. You can see them. Plus, I'm just trying to get the math mindset behind it, right? So now we move on to number 4, and it says, how fast was the rocket traveling when it was first launched? How do you know? So this is asking for V naught, or V initial, the initial velocity that it starts in. So I just wrote down the slope. Slope equals rise over run, right? And now the slope of the velocity graph, we know, because that's the acceleration graph, is negative 10 meters over second squared. So to figure out the initial point, I made an equation, negative 10 equals negative 2 V naught over t, because that's the slope, negative 10, and I'm plugging in rise over run. The run is t because, as you can see in these graphs, it's just that's the x value. So, or the horizontal value. Now, negative 2 V naught I got because that's the rise. So I plugged in that equation for all of them using the t I got when it hit the ground, and found all the initial velocities. Now number 5 asks, is the speed when the rocket was launched different from when the speed was just before the rocket hits the ground? Explain your logic. So I said, no, they are the same, because since it is a parabola, and since it starts at the same position, ends at the same position, it has the same time with the same...
Mom's waiting for you outside.
Sorry, I don't know where I left off. Anyways, so, it has the same amount of time to accelerate as it does to decelerate, so therefore it's going to go the same speed. Because it has the same time from when it hits to go to 0 as it does to go back from 0, because it's a parabola. Now number 6 says, what is the maximum height of the rocket, and how do you figure this out? So the maximum height is when the velocity graph here, where its area is the greatest, and we figured that out by saying when it's just this triangle, because this is positive, this is negative, so therefore if I took any part of this triangle, it would just lessen this. So we just want to find the area of this triangle, because that's when it's going up, like the cursor I'm doing, up, 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 and then it stays there, and because afterwards it goes down. So I did the area equals V naught, or V initial, times time, times 1/2, because that's the area of how to find a triangle. 1/2 base times height. The base is a triangle, and is t, and then the height is V naught right there side. So I've just plugged that in for low, medium, high, and super, and got my answers, which you can see here. Now number 7 says, was the acceleration different when the rocket reached maximum height? Explain your reasoning why. And no, because we know from our graph that acceleration is always constant at -10 meters over second squared. Okay. Now number 8 says, what is the total distance that the rocket traveled? So total distance is absolute value. So I put total distance equals absolute value of the area of the velocity graph. And to find the area of the velocity graph, you do 2 V naught times t times 1/2, because it's a triangle and there's 2 of them because there's 2 triangles. So the 1/2 and the 2 cancel out and you just get V naught times t. So I plugged that in for all 4 and got the answers. Now number 9 says, what is the total displacement of the rocket? So the displacement's a little bit different. The displacement is not the absolute value. So since it starts at 0, goes up, and then ends at 0, the displacement's going to be 0, because it doesn't travel, it doesn't move anything from its starting to final. So you take the position of the final, which is 0, minus the position of the starting, which is 0, so 0 minus 0 is just 0. Now number 10, are your answers different for the last 2 questions? Why? They are different just because I said because one is absolute value and one isn't. And you know that they're different because one's going in a positive direction, one's going in a negative. So when you do absolute value, that negative now becomes a positive. But with displacement, since it's not absolute value, it's a positive and a negative, so they cancel out. So that's why it's different. Okay, I hope you enjoyed that, and that's my rocket activity, and I'm Jared in period 6.